solve dy by dt plus 2y plus integral 0 to t y dt equal to 2 cos t, given that y of 0 equal to 1, using Laplace transform method. So this is the differential equation, but the differential equation having integral term. So this differential equation also we can solve by using Laplace transform method. For this we need a formula. This is the formula. This fourth formula we need to apply this type of problem. You see, this is very important formula. Laplace transform of integral of y of t dt, which is equal to 1 by s y bar, where y bar is equal to L of y of t. So this is very important formula for this problem. Okay, now the given differential equation can be rewrite as dy by dt. Simply we can write y dash of t plus 2y, y can be written as y of t, plus integral 0 to t, this y also can be written as y of t dt is equal to 2 cos t. Okay, now this differential equation I am going to solve by using Laplace transform method, so that taking Laplace transform on both sides. Taking Laplace transform on both sides. Okay, so now L of y dash of t plus 2 into L of y of t plus L of integral 0 to t y of t dt is equal to L of 2 into cos t. Okay, now we know the formula for L of y dash of t. The formula is s y bar minus y of 0. This is as usual formula, plus 2 into L of y of t. The L of y of t is y bar. This is also our first formula, y bar, plus L of integral of y of t dt. Already we know the fourth formula. This is 1 by s into y bar, which is equal to, take 2 outside, Laplace transform of cos t, s by s square plus a square. A is 1, so 1 square 1. So this is the formula. Okay, now here I am going to substitute the given condition. The condition is y of 0 is 1. So put y of 0 equal to 1 in the above equation. So that s y bar minus y of 0 is 1 plus 2y bar plus 1 by s y bar equal to 2s by s square plus 1. Okay, now already I told you I want to find out the y bar term. The y bar terms are this, this and this. Only one term not having y bar. This term can be taken into right hand side. So all the remaining term can take y bar outside, so that s plus 2 plus 1 by s into y bar can take outside. So 2s by s square plus 1, take this minus 1 this side, plus 1. So that now this is LCM. This LCM is, take s, so s square 2s plus 1 into y bar is equal to, take LCM here, so 2s plus 1 into this s square plus 1 whole divided by s square plus 1. Okay, so for the simplification we will see. Okay, now this is s square plus 2s plus 1 by s into y bar is equal to, this side s square plus 2s plus 1 by s square plus 1. You see, s square plus 2s plus 1, s square plus 2s plus 1, this will be cancelled. So what is y bar? Which implies y bar is equal to, take s this side, s by s square plus 1. But you see, we know y bar is equal to, what is y bar? Y bar is equal to L of y of t. Therefore, this y bar is L of y of t is equal to s by s square plus 1. But the solution of the differential equation is always y of t. So keep y of t in the left hand side, take L term in the right hand side. So that y of t is equal to L inverse of s by s square plus 1. So this is direct formula. Inverse Laplace transform of s by s square plus a square. A is 1. So this is cos at. A is 1. So that cos t. Therefore, y of t is equal to cos t. So this is the solution of the given differential equation.